Data, I'm going to have Blackium, I had 32. For Brownium, I had 43. And for Whitium, I had 27, right? So that's the number that I counted up, the whole pile. Then you guys had to mass that, right? So mass of pile. And again, just pull from your data table. Don't use mine. Pull from your data table. So you did number of beans. Now we're doing mass of beans. So mine, I'll just go ahead and put 38.2 grams. And this one I'll say 30, should be more, which means I'm going to have huge numbers. So 40.32 grams. And then I'm going to say 34.3 grams. Okay? Make sure you have grams for all three of those, by the way. Because you can't leave naked numbers. All right, your next column. So on our data table right here, it says average mass of one beam. So that's great because that tells you what we had to do, but it doesn't help you with your final calculation, and that's what I'm trying to help you with right now. So I need you to put the isotope mass. Okay, put your isotope mass. And the reason we're going to do that is because when we go to do the final calculation, it's going to look just like your notes, right? All right, so isotope mass. So put a star right here, and then put the star down here, because you're going to show that calculation. So when you had to solve for isotope mass, what did we have to do? So in this column, what did you have to do? Mass divided by number. Perfect, right? So it's going to be mass of pile divided by number of beans. Right? To show your work for at least one row on your whole data table. So we're going to just do Blackium. So my mass of the pile. So here I'm going to have 30.2 divided by 32. So I got 3738. So you should have taken it to 4 decimal places, just so you know, 3 or 4. If you didn't, you can technically do it today. It doesn't really matter. So I had that amount. So I'm just going to put that back into my little data table. If you have any numbers in this column greater than the number 1, you need to talk to me, because it just means that you flip-flopped your calculation. You should not have anything greater than 1 in this column. Okay, so I got my 3 masses. Did you guys get yours? Yes. We're finishing up. I'm going to move on. So the next one is percent abundance. So I'm just going to put percent abund. So we're now right here, percent of beans, right? So if you already did this calculation, then cool, write them in, that's fine. But I'm going to show, because we got to show our work for that one too. So go ahead and put a star right there. We're going to put a star down here. We're going to say percent abundance. Because it's important to always inform someone reading your lab report how you came up with that number, right? The showing your work kind of thing that your math teachers always make you do. So for percent abundance on the lab, you took your number of beans and you divided it by your total. So I haven't shown my total up here yet. Sorry, forgot. We're going to add your number of beans all together. My total is 102. Okay. So for percent abundance, you're going to take number of beans and you're going to divide it by the total number. You're going to get an answer. Once you get that answer, you multiply it by 1,000 to make it a percent. So again, show your work for the first line in your data table. So for me, I'm going to do 32 divided by 102. And multiply that by 100, and I get the answer 31.37%. So then you can go ahead and put the percents in there. So I'll give you guys a couple minutes to finish that part of your analysis, okay? If you are patiently waiting, go ahead and title this next section. This is your last calculation with me, okay? So we're going to calculate average atomic mass. Basically, I want to make sure that you're seeing the connection, that it is exactly what we did on Friday. It is exactly the same thing. Okay? Did you say, oh, I'm still confused? Yeah, okay, all right. All right. So, calculating average atomic mass. So let's go ahead and make sure that so this is all of our information. So basically this last calculation comes from those last two columns, right? So you had this yesterday. It just, the wording on your paper looks a little wonky, and so I wanted to make sure that we understood that. So it's these last two columns, that's the numbers that you're pulling from. Okay, so for calculating average atomic mass, what I would do, and this is a good habit to get into when you get to the word problems like this, just label what your numbers are, right? So I have blackium, brownium, and whitium. Okay, we know that those are my three isotopes. I would always list your percent abundances first, right? So if you list the percent abundances first, you're basically just taking them straight from your table so that they're ready to go. So I have this one, that one, and that one. All right. So I just listed out my percent abundances, just so they're ready to go. So according to our little procedures on Friday, what's the first step of our process?
The decimal.
Yep. Scooch that decimal 2 to the left. We're basically dividing it by 100. You're putting it back in decimal form, which is really annoying. I know I just made you take it out of decimal form, but it's okay. So we're going to scoot that decimal 2 to the left. So your step number 1 is you're taking that decimal going 1, 2, 1, 2, 1, 2. And you're going to rewrite those numbers again. So 0.3137 is mine. I'm going to stop saying it out loud so you can focus on your own numbers. I'm just moving everything into decimal form. Step 1 is done. So 2. Step 2, what are we doing?
We are multiplying abundance by the isotope mass.
Right. So we have these three numbers right here. We're going to multiply them by the isotope mass, which you guys just labeled in your data table. Okay? So you're basically taking that percentage and you're taking it times that, times that, times that. Okay? So move the decimal 2 to the left on all of them. That was step 1. Step 2 is we multiply them by isotope mass, which is this column on your data table. Isotope mass. So the reason I'm not having you use your lab page is because it doesn't tell you to change the decimal on it. And I didn't want you to confuse that, okay? All right. So you're going to go ahead and do that. Let's get our numbers. What is that third step going to end up being? I did. There you go. Yep, so you're going to add those all together to get that final answer. And that's the ultimate thing that you had to get from this lab, was making sure you get that final answer. And that's the part that you're going to share with another group. So as you're coming up with your final answer, yours will not look like mine. You won't have 0.9. Sorry, mine is made up. Yours should be closer to 0.3-ish. So if your answer came up to somewhere around 0.3 or 0.2 or 0.4, there's a big range there, then that's good. If it's coming out to be greater than the number 1, let's talk ASAP.